Hello and welcome to the Worldwide Center of Mathematics Advanced Just Regular Problem of the Week. So this week you're being asked to see if you can prove that you can use 7 30 by 30 centimeter or whatever units you want to use squares to cover a 120 by 32 unit sized rectangle. So here we have our two-scale replica of the problem in question. We are using 7.56 by 7.56 centimeter squares of Post-it notes. And so each Post-it note is pasted across 4 and extended a little with another Post-it note to make a rectangle of 30.24 by 8.064 dimension full rectangle. And I believe that's about 3.9 something times smaller than the rectangle we're using. So to do this, we just have to cover this with all of these. Okay. So within a degree of error, we have these two corners poking out, but the math checks out, and it takes about as long to do the math as to make this whole elaborate array. So I did both, and this one's a little bit more fun to do. So I stuck with this for the proof. But this is the proof of how to cover a 120 by 32 centimeter rectangle with 30 by 30 centimeter squares. Okay. So we just did a little geometric cut and paste type proof, but it proves it sufficiently well. You might want to use math to check if there's no trickery going on, but I assure you there is no trickery because the math all checks out. One thing you might want to do is calculate the areas of the squares, but that's more of a checking measure because you would have to know how you want to arrange the squares in the first place. But basically all the geometry boils down to is that we're going to be looking at halves of squares, which are triangles, isosceles triangles, and distances from the center from certain points. So we know that the side of the rectangle is 30 centimeters, and we can calculate the length of this diagonal using since that's a right triangle, we can use Pythagorean's theorem. And we can calculate the length of this. And since we know that we want this cutout part to be 30 centimeters, we can look at just this upper isosceles triangle. And so I didn't draw this exactly to scale, but the notion is still the same. Any triangle that you inscribe with a 90-degree angle here, 90-degree angle here, since they both share this one angle, these two triangles, this one, the small one and the big one, are going to be similar. So in this case, that just means that since this side and that side are the same length, then this and that are going to be the same length in our case. So from there, you should be able to calculate all of the geometry you need, but I prefer the cut and paste, Post-it note approved proof that we just did. So thank you for watching. Stay tuned for links to our website, YouTube subscribe button, and a playlist of more problems of the week. Thank you for watching and have a good day.